Today we're working on 11.3, areas of circles and sectors. There are going to be two formulas that we need to know today or learn today. The first is the area of a circle. The second will be the formula for the area of a sector of a circle. So for the first, the area of a circle formula is hopefully one that you've seen before, hopefully one maybe that you even know by heart already. Obviously for this year you won't need to know it by heart, but for most advanced math classes it is a good one to know. If you're a math team kind of person or plan to be in the future, it's kind of one that is usually an expected thing that you just know. So the area is pi r squared. So remember, pi comes up almost every time we're dealing with circles because it's that ratio of the circumference and the diameter. And so it's coming up here again. It's kind of like working with how we can find a perimeter, right? And then the radius being squared, right? That makes sense because area is a square unit, and this is kind of where we're getting that square unit from. Area of a sector, this is of a circle. So a sector is just a part of a circle. If we had a circle and say we had a sector of our circle, right? And let's just say that the central angle here, right? This is a central angle. That's how a sector is made. We're going to call that x degrees. That would also mean that the arc over here is also x degrees. So either one of those is fine for calling x. The actual sector that we're looking at, though I don't want to shade too much, is that part in there. And then obviously we have the radius, right? And the area of the sector is this part. So the first question you might actually ask yourself before we even get over to this area of a sector is, what part of the circle is this, right? So what if x was 36 degrees, right? If x were 36 degrees, how much of the whole circle would it be? Well, the whole circle all the way around is 360. So 36 over 360 would be 1/10. This would be 1/10 of the whole circle, right? Well, if it's 1/10 of the whole circle, it should also have 1/10 the area of the whole circle, right? So there's two different ways you can write the sector formula. The first, which generally I like better, is the area. This is the area of this sector over pi r squared. That's the area of the whole circle, will be equal to the measure of the central angle over 360, right? So what part of the area are we looking at? Over the whole, the area of the whole circle, the part of the circle over the degrees of the whole circle, right? So part over whole, part over whole. You can also look at it as, though I usually don't, we also do x over 360 times pi r squared, right? Visually, this one might actually look better for you. There's a reason why I don't use it, and we'll do at least one of those. It doesn't work as well if you're trying to find the radius. You have to kind of move things back, and this one kind of works better for me as a way to do it because we've done part over whole so many times as a proportion. But here you can kind of also think about it like this is how much of the circle times the area of the whole circle, right? So how much of the circle is it? Well, it's x over 360, and the area of the whole circle, it's that part of the whole circle. All right, so we're going to find some areas of circles. These ones should be fairly easy. We're going to do to the 10th. You'll always want to just follow your directions on whether we're going to the 10th or the 100th. So we have a radius of 5 inches. So the area is pi r squared, and that is 5 squared, which is 25. So we get 25 pi. A lot of times when we're in class doing paper tests, I will actually have you leave it as 25 pi. I like it better in general. However, with the online stuff, using pi is often a lot more difficult. So again, we're going to go to the 10th, 78.5 inches squared. And we're going to look at one more of these. Kind of the only way to throw in a trick question with these, right? The area is pi r squared, but what is the radius, right? The radius is not 88, right? It is half of that, which is 44. So we get 44 squared pi, right? So again, you want to look for the radius, not the diameter. And 44 squared pi is about 6,082.1 meters squared. Or if you had done it exactly, you would have gotten 1936 meters squared, pi, okay? Pi meters squared. Which does not look like what it says anymore, but that's fine. Again, the answer you're going to give is rounded to the 10th usually. Find the diameter. Now, if I give a question like this, always check what you're looking for, right? Could just as easily ask for the radius. I'm asking for the diameter here, so make sure you find which one it asks you to find, right? Find the diameter of a circle with area of 490.9 millimeters squared. Also note, maybe I didn't say it above, I kind of did. We're in area, and area is in units squared, right? If we find the radius, then we take that square away because a radius is not a square unit, it's a length, right? Find the area of a circle, right? Sorry. Find the diameter with an area. So we're talking about area still, right? It's just that this time we don't know what the radius is or the diameter. We're looking for it. So the first thing that we do is, what do we have? We have the area, right? So area equals, so this is the area, is 490.9 equals pi r squared. And we're solving for r because once we have the radius, we can find the diameter. And so once we divide by pi, these pi's cancel out. We're left with r squared equals that. If I were working on this, I would just take the square root at this point. So r equals the square root of 490.9 over pi. Or you could do 490.9 divided by pi. You're going to get a number that kind of runs on a lot. Probably, I didn't do it beforehand, 490.9 divided by pi. Yeah, you get 156.26. And you can, on most calculators, take the square root of your answer. That's what you want to do. Otherwise, you shouldn't really round until we get to our answer. So this is a better way of doing it than dividing if you don't have a way to put in your answer for the old part. This is about about 12.5. This is not what the question asks for, though. The question asks for the diameter. The diameter is about 25 millimeters. Right? Twice the radius. All right, we're going to look at some areas of sectors. So if we have our circle, we have a sector, it's going to have a measure of 45 degrees and a radius of 3 feet. And I'm not going to shade the whole sector, but the part that you're going to find the area of will always be shaded. So it'll say find the area of the shaded sector, right? So we want to find the area of this part. I like the formula area equals pi r squared, area over pi r squared equals x over 360. And then we're just filling in the parts that we know. We don't know the area, so that other formula we talked about would work well here as well, that we're going to multiply both sides by pi r squared anyway. We have area over radius is 3, so we have 9 pi equals 45 over 360. All right, we'll multiply both sides by 9 pi, area equals 45 over 360 times 9 pi. So again, if you thought using that second formula we had for the area of the sector would be better, here it probably would work out better for us. And in your homework it might as well, but if we were trying to find the radius, then it's usually easier to do it the other way. So we have 45 over 360. So it is 0.125 of the circle. And we're multiplying that by 9. So we get 1.125 pi exact, or 9/8 pi. And believe it or not, my calculator just died.